Hey guys, how you going? I'm back here at a Cavendish Road project. The boys are getting stuck into the framing. A little bit noisy here at the moment, but come with me. I want to show you where we're at because the boys are doing a cracking job. So from the past videos, you would have seen we were doing all the work under the house, getting all the undercroft area ready, footings and slab. That's all been completed now. The boys have got all the gravel underneath the house. And we're currently, we'll use that as a storage area during construction. They fabricated all the posts and built the subfloor. So that area's come along really well. The idea of doing the gravel underneath there is we put the geofab and plastic down, we put a 75mm gravel layer over the top, keeps underneath the house beautiful and tidy, prevents all the weeds, prevents mildew. And when you get a subfloor like this that's only within 400 or up the far corner, it's only 400mm, it gets to 1100 down here, but it avoids moisture sitting under there and helps the moisture get away and allows good drainage. We're laying a new tongue groove floor, so we put a particle board subfloor down to that we can build off during construction. Then once the plastering's in, we'll lay tongue groove timber flooring on top of this. By putting the gravel underneath and the geofabric, it stops a lot of the moisture getting absorbed out of the ground, humidity and stuff getting sucked up through and affecting the timber floor on top. So your timber floor tends to last a lot better, but it stops all that movement, so you don't get as many of those cracks in between your boards and keeps the environment more consistent. If you're using a good quality floor supplier and installer like we do, they actually will not lay a floor. If we got them out to do this job, they would not lay the floor on that subfloor if there was no protection and gravel underneath there. So when you use good quality trades and contractors, they will educate you on how you should be doing things on your job so that you can do a better job overall. If you come up here, I'll show you what the boys have been getting stuck into. So one of the things I like to do by doing these videos is to educate people on where the costs go into the building. So many people with these renovations think that they're small renovations and they wonder why they cost so much. And as you know, I keep banging on about, it's all the stuff you don't see that makes the difference. It's the stuff that matters. So on this little extension here, it's a long, narrow extension. So if we come back in here, I'll just quickly show you. We're in the old house. So while we're working on the back, getting the footings and slab and everything in, the boys were smashing out all the new framing work in here. So what's going to happen is you're going to walk through this old house, and when you get to here, it's going to open up into a huge two-story area, a big void over the kitchen and dining area. So that beam back there is the edge of the void. So from there to above where I am here, I think it's about 6.5 or something meters, 7 meters. The whole area, and then from side to side is going to be 2 stories, so around 6 meter high ceiling. So what happens when you get a large narrow building, you've got to brace it, you've got to stop the thing from wobbling around. A lot of people with those 2-story void walls, project style builders, and even a lot of it comes back to the designer and the engineer you're using. They will do walls like that with double or triple studs. So what that means is generally the external walls of your house, you should have your studs at 450mm centres. When you have big tall walls, generally over 2.7 or 3 metres, you then start to double or triple up your studs. So rather than having one stud every 450mm, you have 2 or 3. And by laminating the stubs together, it does give you a bit more strength and stops the wall sort of wobbling around or getting a big bow in it. The engineer that we use on our jobs is Paul Kakia. He does a fantastic job. He works in really well with Aaron and I. Aaron is from Green Coast Design. He's a designer on this one. By putting big wind beams, so you can see there we've basically got a big wind beam running along that entire opening. So what will happen is there'll be large big sliding doors and windows going underneath. We then break the wall by putting that beam in, and then we've then got some large window openings above. Then we can reframe from the top of that beam up to the pitching plate, which the roof will sit on. That whole wall will be as stiff as anything. Even though it's a big 2-story volume, when it gets wind blowing against it, it can't move because it's got that big beam in there. The other thing that happens here, we'll come out here and show you around. When you get up to this area out here, where we've got the pool running alongside the house, so we've got a large 10x2 lap pool right down the side of the house. We've got some steel posts in here, but that whole wall is going to be glass and windows and some louvers and stuff. So again, you've got nowhere to put your bracing. So basically that whole side of the house is just floating around doing nothing. So to brace that, we've used this beam here. The engineer has designed it. It's got a welded connection over there, some big bolts in it. That beam then comes across and it's sitting on this large portal frame, which one of our chippies has done a fantastic job on site doing. And we've made that bracing wall as big as we possibly can. That means that this wall holds the building, so it's got all its bracing in it. When it can't move around, so it's stiff as anything, and that by transferring that to the other side, because it's a two-story narrow building, it can't move. What's also been done on this one is the connections to the slab. So to make it super solid, make the house very rigid. So again, it's all what you don't see that makes the difference. So by making a house rigid, it eliminates lots more issues. So you don't get any cracking in your cornice, around your doorways, your architraves. You don't get any movement in your frame. Like, everything stays nice and solid. Your door's always open and closed. You don't get those little hairline cracks along the tops of your cornice or your internal joinery and all that sort of stuff, because the building is solid. So down here, this big bracing frame is connected to the slab. We got two M16 rods that will get nuts and washers on them, but we've also got these 20mm Rio bars. So they come up along the side of the frame 300mm, but they go down into the slab. So they were placed in the concrete when we poured the slab, and they're shaped like a big L. So they get pushed into the concrete. So that means there's 200 to 300mm in the slab, surrounded by concrete. It cannot move. And then it gets welded up the side of this bracing frame. So you could pretty much run a semi-trailer into this and it will not move. It's as solid as a rock. And then also, when you get to areas like this behind me here, so you can see here I've also got another big steel beam behind me. I'm currently standing in what will be the stairwell of the house. So again, the outside wall of this house, you're going to have this huge big 2-story volume of wall. Again, in the old days, or a lot of builders still do it now, that would be double or triple studs up the 2-story volume, which again, you're relying on the timber. Like, if you built that wall, you'd be able to push on it and the wall gets a bit wobbly. You're relying on your actual stairs internally to be fitted off and fix that wall to give it a little bit of strength. By running this, what we call a wind beam, along the center of this wall, the wall then gets split in two. So we have a stud wall underneath it and a stud wall above it. It's strong as anything. The wall won't wobble. It'll be nice and straight. And that'll also flow through to the cladding. All this sorts of stuff shows up in the finished product. So the better your frame is, the better the overall job is, the better finish you get on the plastering, the straighter your cladding is on the outside of the house. So everything starts from here. It's all the stuff you don't see that makes the difference. If you come up here to the back corner of the house, you'll see we've got we've built a low height retaining wall around the back. That is because the earth, we're on a sloping block here. So that is to keep the earth on the outside of the house away from the inside of the house, divert all the water around the job and all that sort of thing. But what we've had to do, you see here, you'll see it's all been lined with this red cordon material. So cordon is a termite proofing product. We also put it around all of our slab edge. So it goes right around the edge of the slab. The timber frame sits on that and it prevents termites from coming in and getting into our timber framing. We're going to have a timber frame sitting on top of this retaining wall. So the entire thing gets lined with cordon. And if we come over here, you can see what the boys have done. So we've set everything up right from our set out. So set out on every job is so critical. So the first thing we do on all of our jobs is run a profile around the whole job, and we set everything out. All the grid lines, all the room measurements, all the retaining wall measurements all get set out on the profiles, and then the entire job's worked off it. But we work backwards. So you'll see here, the boys have set the wall up, this timber frame, to overhang the retaining wall. So that means, you can see here, it's 35mm. That means we can run a stud down and pack out over the cordon, and then our gyprock will get fixed to the stud. So the retaining wall's been pushed out 35mm. We get our termite proofing on there. We run our timber over it, and then what happens then? That is just internally, that gets plasterboard. That's one big flush wall. All the termite proofing's hidden in the cavity. And the reason we do the termite proofing on the retaining wall is people don't understand termites travel through cracks in concrete. So we put the cord on there, so when the concrete cures and shrinks, if it gets any shrinkage cracks in it that are large enough, it prevents the termites from coming through those cracks and entering the timber framework. So got young Josh here smashing out the framework, but I'll come over here. So the boys are doing a cracking job on this frame. It's coming together really, really well. But got Brad down there doing some drilling with the magnetic drill. So by having all the tools, magnetic drills, welders and stuff, it allows us to do all the fabrication and all the tasks on our jobs ourselves. We're not waiting for an on-site welder, we're not waiting for a steel fabricator, and they come up absolutely awesome. It means we can control our schedules a lot better as well. Over along the side of the house there, I'll just take you down and show you. It's a little bit noisy down there, but check out the brackets and the detail. So the boys have made up these beams. Because we've got a lot of glass, the steel posts continue up through to the floor system. So you'll see up there, the timber beams have been cut nicely around the steel posts. And if you come on the outside here, you'll see they got massive brackets on to connect everything. So basically, we got, again, this one's a timber one, but by putting these with brackets on, we've got a continuous beam right along, and then that goes down and joins into our large steel wind beam down there. Guys, hope that gives you a little bit of an insight into timber framing. Like I keep saying, it's all the stuff you don't see that makes the difference, and it's all the stuff that costs the money. So make sure on all your projects, if you're thinking about building or renovating, you're using not only a quality builder, but a quality designer and a quality engineer, and also you're using the pack process where you're paying the builder as a consultant to liaise with all these other consultants to make sure that you get a product as good as this. Cheers, guys.